Hello everyone, in today's tutorial I'm going to explain how to control CoolLED Illumination Systems in cellSens using the CoolLED USB the TTL Trigger Kit. This is useful for new illumination systems which aren't immediately supported in cellSens software, and in this example I will control LED triggering of the pE-400max using the pE-6501, with LED intensity modulated using the manual control pod. Once the CoolLED light source is switched on and the control pod plugged in, with no LED selected, use the supplied USB cable to connect the pE-6501 to the PC. Then, using the supplied multi-BNC cable, connect the pE-6501 to the light source. You can see the individual BNCs are labelled A to E, which matched the BNCs of the pE-6501. However, seeing as we're using a 4-channel light source in this example, we only need to use A to D. When connecting the cable to the light source, these go in channel order. So channel 1, i.e. the UV channel, to cable A, and so on. And you can see that the channels are labelled on the light source itself. Once the hardware is set up, it's now time to look at the software. You first need to download the driver for the pE-6501 in Windows. Since the pE-6501 is built on the National Instruments data acquisition device, you need to visit the National Instruments website for this. Use the search to search for NI-DAQ, and you can see in the list here there's an option for the NIDAQ driver. Click this and select the NIDAQ download. This is where you can download the driver. Select download here, and once it's downloaded you can open the file location and you can save this to a memorable place. Now you need to run this file and follow the instructions. Accept the license agreement and click Next. Click Next again. Accept the license agreement, click Next. The installation can take some time, and once you're complete you then need to reboot your system. Once you've rebooted, we'll just double check the drivers have installed correctly. So to do this we need to go to the Windows Device Manager, and in the list here you can see under the NI data acquisition devices, if we expand this you can see the USB 6501, the driver has installed correctly. So the next thing we need to do is to add the pE-6501 to the cellSens installation. Now to do this we need to go back to the original files from the installation and run the setup exe file. And then we'll follow the instructions on the imaging installation wizard. accept all the terms of the license agreement and click Next. We don't need to add anything on this page, so we'll click Next. Next again. This is where we need to add the pE-6501. So if you scroll down to National Instruments, then we can select the NI USB 6501. It's worth noting that if you're installing cellSens for the first time instead of modifying the installation, this page also comes up in the installation, and this is where you will do the same thing and add the USB 6501. Click Next. Next again. Click Finish, and the installation of cellSens is now modified and the pE-6501 is added, so we're ready to launch cellSens. From the Start screen, go to Device List and head to the Lasers LEDs tab. This is where we need to add the LEDs that are going to be controlled using the pE-6501. So working from left to right along this window, you need to use the drop-down menu here to change single laser to single LED. We'll ignore the description here. Then under Type, use the drop-down and change this to NI USB 6501 laser LED number 1. This is going to be our first channel, and so in the description we'll call this something that makes sense to us. So for example, UV 400 nanometer. This is the name of the LED that it will trigger because it's triggering channel 1 of the pE-400. So we'll add the next one using the little plus icon here. Change this to single LED. Call this number 2. And this will be our second channel of the pE-400max. So blue and 450 nanometers. And we'll do the same for the other 2 LEDs. Once we've added our 4 LEDs, click OK. The next step isn't essential, but it's a good idea to test that the LEDs are triggering correctly. To do this, select Device Settings. The default settings should be high equals on under polarity, and the latency should be set to 10 milliseconds. And then you can test that the LEDs are triggering correctly by clicking Test. And then selecting each LED individually. So 400 nanometer, the 450 nanometer, the 550, and the 635. And then once we've confirmed that these are triggering correctly, which they are, we can close this and select OK. Once testing has confirmed that the LEDs are triggering correctly, it's time to set up some observation methods. In our example, there are 3 imaging scenarios we're going to consider: manual sample observation without camera acquisition, manual sample observation in live mode while the camera is acquiring an image, and then automated triggering, for example, to run a time-lapse experiment. So firstly, for manual observation of a sample, we need to create a set of observation methods to trigger each LED. We do this through device customization. Select a new observation method here, and we'll set this up for the first LED, so UV 400 nanometer. Call this on. Click OK, and then we'll assign the fluorophore. Select fluorochrome, then change status to use. We're going to be using DAPI, so we'll type this in, press enter. So that's now assigned. And the way we're controlling the LEDs in this case with the pE-6501 is using the shutter. So ignore the light bulb icons here, we're just using the shutter icons. So we'll select the 400 nanometer shutter, we'll change the status from not changed to adjust, and then we'll open the shutter. This means that when this observation method is used, it will trigger the 400 nanometer LED to on. So we'll set up more observation methods for the remaining 3 LEDs of the pE-400max. So now we have 4 observation methods for switching the LEDs on. However, what we need is an observation method to switch an LED off. But in this case, we just need one observation method and it can switch any of the LEDs off. So we'll create this, we'll call it LEDs off. And we don't need to assign fluorophore for this, we just need all of the shutters selected and changed to closed. We can see that all of the shutters are added here and closed. So that's our 5 observation methods created. We can click OK. Now we can see that these are available in the toolbar here, and they're also available in the microscope control window under observation methods. When we select an LED on, we'll see this illuminate, and we can select LEDs off to switch this off. And you'll see the LEDs illuminate even when the camera is not acquiring an image. CellSens features a setting where an LED is synchronized with camera acquisition, which reduces unnecessary sample exposure and minimizes photo damage. This is the setting we'll use for our next set of observation methods, which can be used in live mode when the camera is acquiring an image. So once again, navigate to Device Customization and create a new observation method. This time for the UV 400 nanometer LED, we'll call it Acquisition and click OK. First we'll assign the fluorophore. Then we'll assign the shutter, but we'll change the status to use for acquisition. We now need to create an observation method for each of the remaining 3 LEDs in the pE-400max. Once all the observation methods are set up, you can select OK. And these have now been added to the toolbar and to the microscope control window. And when we're in live mode for the camera, even though we're just using a simulation camera, so you can't see an image here, when we use one of the acquisition settings, we can see the LED illuminate. These observation methods can now be used to run an experiment, and to do this you need to head over to the experiment manager here and select New to create a new experiment. On the image acquisition drop-down, you can see that all of our observation methods are available to use here. So you can select these and drop them onto the window. This will create a 4-channel experiment. You can change the times here, the exposure times, and of course you're using the manual control pod or LightBridge to alter the LED intensity. And then the rest of it really depends on your experimental aims and your microscope setup, but we have various options here, like a multi-channel acquisition, just drag this over once selected, or a time-lapse loop, select this, and then drag it around. And once you're ready to go, once you've set up all your parameters, simply click Start. And again, we're using a camera simulator, so we can't see anything here, but we have just seen the LEDs flash. So it's all working. So I hope this has given you a good idea as to how to trigger the LEDs of a CoolLED light source in cellSens, even when the light source itself is not fully supported yet. But of course, if you have any questions, then please just get in touch. Thank you for watching this CoolLED tutorial video.